All right, so now we're going to get into web crawling and scraping. How many of you, have any of you guys ever done this before? Ever played around with it at all? Okay, so you might hear the words web scraping or web crawling. They do mean different things, but people use them interchangeably just because they're ultimately pretty similar. You should think of web crawling as step 1 and scraping as step 2. So crawling is going onto the website, downloading the HTML or the JSON or the XML or whatever format it's in, downloading it somewhere so you can save it. Now you have a snapshot of data. Whereas scraping is actually going back to what you've crawled and extracting the data from it. So Google just crawls and indexes all this stuff. They're not actually parsing the information and like making a data set out of it. I mean, they do that as well, but that's a whole separate thing than their search engine. So these are the differences if people are misusing it, these definitions. So before I get too deep into HTML and web scraping, I just want to show you guys one more thing. I feel like I'm always saying that. One more thing about R. There's this package called magritter, and it's how we use pipes in R. R just recently, not even a few months ago, just came out with their own native version of pipes. This we're not going to talk about that. We're just going to talk about magritter. I like it better. I've used it before. Anyway, essentially what it is a way to make your code much cleaner. So for example, you'll notice in the last homework we just did, some of these solutions are pretty long, like this one, right? It's a pretty crazy solution. I don't know anybody who can really sit here and like read this. You have to really chunk it up piece by piece. So what magritter allows you to do is do this. So for example, let's say I wanted to do some sort of crazy multiple function calls in a row, right? But I have this one vector and I'm just going to pass it along, right? So I'm going to take the average of X, then I'm going to take the exponential of X, then I'm going to square root it, then I'm going to print it. So what magritter lets you do is you kind of write it in the reverse way. So you start with X, and then you take the mean, and then you take the exponential, and then you take the square root, and then you print it. So this to me is really intuitive and readable because I can tell you exactly what it's doing. It's almost like a waterfall. Like I start with X, then I go to mean, then I go to the exponential, right? And so on. Whereas this one, this is an easy example, but in this one, it's not so easy of an example, right? Where it's kind of crazy. So it just allows for more readable code. There's some other things you can do with it that I'll talk about in a second. But that's all you should really think of it as, is that it just allows for multiple function calls in a row using the same starting point. It makes it a lot easier. So here's an example of a few different ways you can use it. If you remember, we had used rnorm in the past. It takes 3 arguments, the number of elements you want, the random number generator, like how many numbers you want, what the mean, and what the standard deviation is. So if I pass one argument to rnorm, like 5, it's going to say n equals 5, and it's going to default to mean equals 0, standard deviation equals 1. And it'll give me some output, right? So magritter always puts the whatever's on the left-hand side into the first argument by default. However, if you want the n to be 4, and instead you want the mean to be 5, you will put a comma and then a dot. So for example, if I have this names data set, right? If I wanted to do, let me see. So this one right here, if I wanted to find this sub 1, if I had magritter, I could do, let me just do this part. I could say names, and I'm going to put this here, right? So this is the first argument, so technically I don't have to even put it there. but to be explicit and for me to read it, I think it's helpful to put a dot because that's where it's going to put it. But I also want to put it here. And I also want to put it here. So instead of having to write names out multiple times, I can just put these dots here. So sub1 looks like this. It's going to look the same. I trimmed the white space. So now if I wanted to also trim the white space, so it's a pretty flexible, pretty powerful way to do pretty simple stuff. It's really just to rewrite your code. I have some more examples of how you can use this dot. But we're going to use MagRitter a lot in this section. Are there any questions about it? Does it make sense? Okay. So HTML. HTML is like the basis of the internet. It's what most websites are originally coded in. A lot of websites have JavaScript or other different languages that they're using to pull data in from other databases and stuff like this. But the basic format is usually HTML. So what is HTML? You should think of it exactly like a list in R. So if you are kind of familiar with what lists look like, you could think of HTML exactly the same, where it has nodes and each node has its own children or other nodes. So for example, we had that ATM data set before, and then one of the arguments was name, and then that had also multiple arguments that were or items, first name, last name. So the HTML, that you could think of this as like the main document. And then you have the head with the title, body has a header and a P, which is per paragraph, and then that, ends the body, ends the HTML. So you can see how each different item has its sub items or not, right? So this H1 doesn't have any sub items, but this body has these two sub items. Does that make sense? Okay, so HTML is, you should think of it like a tree, like lists in R if if you're familiar with that. That's all it really is. So when we're going to try to find things on pages, we have to tell it, like, give me the head and then maybe a little caret and then title. So you have to kind of direct it to where you want to go within the HTML tree object. Okay, so what is crawling? Crawling is how you you just access the web page. You effectively load it such that all the data is on the page, and then you save it. Now, this is helpful for two reasons. One, you don't have to re-crawl or re-scrape, right? Once you have crawled once, you can save it, and then you never have to go back again. This is helpful because you're not going to overload their servers. You're not going to break any rules. Maybe you'll be less likely. You only have to do it once. Also, websites change constantly. Suppose you wanted stock prices from Yahoo or something. You can get stock prices anywhere, but suppose you want it from Yahoo and it changes every day. By crawling every single day, you can have a catalog of this data that presumably gets deleted every day and changes often. So having crawling is really important, not just scraping. So they're both important. So before I kind of get into the actual code, there are these things called robot.txt files. Any self-respecting website will have them. Some of them, sometimes they don't have them. This is a bad idea, but I have some examples here. So for example, here is basketball reference. This is the database where I got all the Knicks data from. Essentially, the way you read this is it tells you which user agents are allowed to do what. So this user agent, href_sbot, is not allowed to do anything. They are apparently banned from the site. Now, this doesn't stop them from scraping basketball reference, but it just says like, hey, we don't want you doing this. Like, you're not our friend anymore. Like, you're bad. User agent star means everybody. So nobody is allowed to go to any sort of link that has this within the URL. So if you see /7103, you're not supposed to scrape it. Same thing with game log, splits, on, off, lineups. A lot of this stuff, Battle Reference has a membership or something that you can purchase to get certain data exports and stuff like that. So they don't want you scraping it. That's pretty much why. And they also have this one thing called crawl delay. So each call you make, each request to the server you make, you're supposed to wait 3 seconds between each one of these. This is so they can maintain service for everybody and you're not just overloading them. Now, sometimes again, Battle Reference, I've never obeyed anything that they've ever said, and it's been fine. I've never been blocked. But I've been blocked from other websites. I've gotten my IP banned. You have to use VPNs. It's a whole annoying thing. And crawl delay is one way to make sure that that doesn't happen. Here's the CDCs. Much more comprehensive, right? They also have a sitemap here. They've got all sorts of stuff. And then sometimes you'll find little cool things like Nike's is pretty cool. They have a Nike swoosh at the bottom in text. I just like that. All right.
How do you find those files?
So you go to the main website, like what's your favorite website? ESPN.com. You go here and then you just type in robots.txt. So here's ESPN's. They don't want you to do anything, apparently.
So when they don't want you to do it, but if you do it, can you write a paper and publish it, or is that like forbidden? I mean, on the one hand, that's on our website, right? I mean, unless it's like maybe stored but not publicly available data.
There's a interesting court case you might like to read, where this bot was scraping LinkedIn information, and the judge ruled that because it was public information, they're just collecting it faster than normal humans could do, but it's all public, it's all there. So what's the difference?
That's kind of what I'm thinking, right?
Yeah. No, most of my, like a lot of papers I'm doing, I've been blocked from the website I've been scraping. And it's fine. I just use a VPN and you change where you're located and they don't recognize you anymore, or, whatever you got to do.
Yeah, but you don't run into situations, or at least probably it's not common to run into situations where like they block you and they have some legal reason that you can't. I mean, if it's on the website, right, everyone can see it, then you should be able to report.
Right.
Yeah. Okay.
Yeah. I think as long as you're not somehow circumventing some sort of paywall or circumventing some sort of something like this, you should be fine. For the most part, I think you'd be able to feel it in your like gut if you're breaking the law.
Like as long as you don't have social security numbers of these basketball players.
Yeah.
Okay, cool.
So that's just something I want to just put out there into the world, saying like, hey, I'm at least trying to inform you guys that there are something of rules. The way you'll see people talk about it online is mostly in reference to like politeness. Like these are all things that it's like, you go into someone's house and they say, hey, can you take off your shoes? That's what a crawl delay is. You're just kind of respecting their rules. All right. So setting up our script, I'm going to start a new script here. Sorry, I haven't posted these out. I will get to it after today. But anyway, there are these three major libraries that we're going to use, pretty much just these two. But this one is becoming more and more prevalent. This is the JSON package or library. I was saying maybe 2 days ago or yesterday, it's all kind of blurring, that a lot of government places are changing their output from CSV defaults to JSON defaults. So this is something that you're going to have to kind of be a little wary about. So we'll load in all three. And we're going to create a folder. So I am going to have this folder, Empirical Workshop 2021, scraped HTML. I guess it should be crawled HTML, but whatever. So let me delete all this stuff. So this is our folder. It's empty right now. So we're going to crawl one page. So the link we're going to try to grab is this Nix data that we've been using for so much, right? So here's the database on the internet. So what we're going to do is we're going to take the link. Let me just copy this whole thing here. We're going to take the link, save it. We're going to read the HTML. Maybe I should. So we're going to read the HTML. You'll see here it's a list of 2. If we open it up, you'll see a node, a doc, and an attribute. Don't even worry about it. It's the HTML file pretty much loaded onto your R environment now. Specifically, it's all the HTML that's in the background of this. And all we're going to do is we're going to write this HTML to our folder. No. Oh, it's right here. So if we open this up, it'll look exactly like it, right? But now if you look at the file path, it says users Alexi desktop empirical workshop, right? So now it's local to my machine. Now this HTML file appears on my screen on my computer only. So that's it. That's as easy as it is to scrape a basic HTML file. You just put in the link, you read it, you write it. It's all done. So now you might want to start pulling some stuff now, but let's just keep talking about how to crawl more difficult pages. So how would you crawl multiple pages? Well, you would use a loop, right? You're not going to write this code 10 times. Instead, you're just going to use this loop where you're going to vary the year. So notice it's a little difficult when it's like this. So notice how I have my paste 0. So I have the same exact structure as this, but I've just put the year in instead of 2019. So each time through this, it's going to go from 2010, 2011, 2012. Each one through it, it's going to read it, and then it's going to write it. And it's going to write it as this first argument right here. And then it's going to just be in that folder. So if I run this, but I'll open the folder first so you can see. So it just wrote all of those at once. So now I have the 2013 roster I can check out. So Kadeem Allen was the first guy before, but now it's Carmelo Anthony. So now we have all these crawled HTML files on our computer now. Are there any questions about that so far? Okay.
So each page is written as a separate file then?
Yes. So each page, each HTML file is its own thing.
So, I mean, are they big? Do they take a lot? Because I'm just thinking like if you have to go through a lot of pages, I guess that's
each page is different. Like each website will be different depending on how much stuff is on the page.
Mm-hmm.
These are pretty small.
Yeah, okay.
Okay. So this one is super easy, right? We just went to the website, crawled it, that's it. But there are websites where you have to click on stuff, you got to log on to stuff, you got to do all sorts of stuff, right? So let's think about this website. I'm gonna close all these. All right, so let's take a look at this website. So this is 500,000 people on government websites right now. Here's a bunch of different stats about government websites, blah, blah, blah. But if you notice, when I load it really quickly, you'll see 3 dots here. So see the 3 dots? They're like really, really quick. Essentially, if we try to take the HTML, what's happening is R will take the HTML before anything loads. So because this website, what this is doing is actually pulling from a different website. So it's pulling the all these numbers and figures from other things. So it's executing scripts to do this. So how would we get these numbers? Well, let me show you how we would get. This is a little bit more into like scraping stuff. So if you're looking to try to get this number, what you would do is you would right click, hit inspect. This is for Chrome. You click on the number, click inspect. And it's going to open up this crazy looking thing, right? But pretty much it's going to highlight this H2. And if you hover over it, it's going to highlight this number. And you can see ID, current visitor, data, and then it has the number here. So what's actually happening is it's pulling from a different source. So if we go up to this tab, we have elements. If we go to network, and let's just reload the page, you're going to see all these different things get pulled. I'm going to click stop recording up here. So this network tab will record all the information that's kind of coming through your computer. So for example, the first thing that gets loaded is the website shell, right? So the basic one, the one with the ... And then it starts to load this logo, bundle.js. This might be some code. SVG, this looks like another logo, all sorts of stuff. And then towards the end, you'll see that it's loading these XHR. So today.json, devices.json, all these .json stuff. So what these all are the data that's being pulled and then filling in the website, filling in that shell. So for example, if I read this HTML, this would be like scraping a little bit, but I'll ask for the current visitors node. If we go back here, this is the ID is current visitors. So the way you access the current visitors node, if there's an ID, you just put a hashtag and then current visitors. And then you look at the HTML text, it's ... So it hadn't been filled in yet when R originally pulled the HTML shell. So rather, they have this API, so realtime.json. If we go to find it in our networks tab, realtime.json. Here's the response. So we have name, real time, sampling is blank, query is all this stuff. But anyway, active users or active visitors is the number we see here. So you might say, how did you find this realtime.json? You're always going to want to look for XHR. These are data files that are being pulled in. And then you're just going to have to go through each one of them. There's really no good answer. Sometimes there's a way to look like, I know, for example, devices is probably not the one I'm interested in, but like today, that might be something I'm interested in. Or, top countries. I know this is not top countries. Sometimes you just have to manually click through them. Like this one, if I click on today, this doesn't look like, this has date and hour. This is definitely not this number. So I just know that real time is that. So there's a little bit of effort you're gonna have to go through. But if you wanted to create a time series of the number of people that are on government websites right now, they provide the hourly data, but maybe you want to do it at 10-minute intervals or something. You'd have to scrape this over and over every 10 minutes and pull this number. So if you pull that link, that realtime.json, I go back here, I right click, copy link address. I open it up here. Here's the today data. I wanted real time. So this is just the website. This is just an API that they use and they pull from. So if you just copy this and you scrape this instead, then you can get the data pretty easily. So in my little notes here, I use from JSON instead of read HTML because this is a JSON file, right? .json. And then it'll just give me the this entire data set as a list. And if we just do it, we can kind of explore it a little bit. If I look at this, we have all these data elements, right? So if I say $, I have name. Name is just going to be an individual element, right? So real time. I look at sampling, it has a little bit different symbol next to it. This means list. So this is also a list. So if we look at this, it's an empty list. Query, meta, data. This is probably the thing that we care about. We have one element here, active users, active visitors. So once you read the JSON, you're going to have to kind of poke around in it a little bit until you can find a data section or some sort of data frame that you want to use. Sometimes you might have to manipulate the JSON a little bit to kind of work with you a little bit better. But this is how you would access their APIs if it's dynamically generated. Any questions about that? This is really hard because this is really idiosyncratic between different websites. So you're going to have some websites that are going to have all sorts of different APIs that they use. Some of them aren't just a static link. Sometimes you might have to change the name here, all sorts of stuff. Okay, this next one is teaching you how to log into a website. So for example, Stack Overflow is a really helpful website for coding help. Oops. So if we go here, I think I'm already logged in. I can maybe log out. Okay. It keeps logging me out automatically. So if you guys would go to this website, if you don't have a Stack Overflow account, it probably looks somewhat different than what I have. But effectively, what you can do with Rvest, which is this package that we're using for read HTML, also like that, you create an HTML session. So a lot of these websites, I guess this one will have it anyway. If I do HTML session for this, you can look, this is really similar to read HTML, but now you could think of this as a little bit more of an active environment. So for example, if there's a search bar or buttons to push or all sorts of things like this, you can actually do that. So if I wanted to look for HTML forms, there's one form and it's a search form. So pretty much this box right here. So if I inspect this, you'll see input name equals Q. Oh, here's form ID equals search, right? That's what this search button is here. So if you wanted to use this search form, you can do that. So you can save this as a form. Well, let me just kind of go through what I have here. So I picked the form on this link. This is the one where I'm not logged into. So maybe you guys can use this link, or maybe they've changed their website since I've made these slides. I'm not sure. You can create a session. You can find the form. If I look at the form, there's two here. So there's a search form, so that top one, but then there's a second one. And the second one is a login form. So we have this F key, this SSRC, and then these are both hidden, right? So you can't even see these. But then you have an email, a password, a submit button, and then you have these authorization things that, again, are hidden. So this is what you would see. You would see an email, password, and a submit button to log in. So we're going to save the HTML form as an unfilled form, just named it form unfilled. We're going to save the second one. So notice how there's two here because it's a list of two. I'm going to keep the second one and I'm going to overwrite form unfilled. Then I'm going to take form unfilled and I'm going to set some values. So for my email address, I'm going to put my email. And then for my Stack Overflow account, I'm going to put my password. I don't actually use this account, so I don't feel bad sharing this password. But if you wanted to log in, this might be good practice. Finally, this next step is not common. I'm not sure why Stack Overflow doesn't have this, but apparently field 5 doesn't have a type. button, or it's not working manually. I'm not sure. But anyway, you fill it as a button, and then you just say, submit this form. I'm going to start with session. What form am I going to submit? Is this form.filled? And then post as URL. So just the original URL. Once you do this, you should be logged in. And then if you try to read the HTML from your session, it'll be a different HTML because you'll be logged in and you'll be able to observe the first few questions asked or whatever it might be when you log in. So submitting, and then you can jump to different things and you can start to see what exists there. I left some stuff commented out here. This is just to try to get some different questions that were being asked on Stack Overflow. You guys can look at it later. Again, this is a little bit tough because it's so idiosyncratic between different websites. You can find Arvest help all online. There's tons of stuff. You can email me and I can take a crack at it too. I don't mind. Now, one thing that I've been really into recently is, I don't know if you guys have gotten into the whole NFT stuff, but I was pretty into NBA Top Shot, which is like NFTs, but for basketball. And essentially what it was, you have these highlight plays, and then they have serial numbers. So the serial numbers are really correlated with price. So what I was doing is I built a bot to go on there, keep scraping different NFTs with the serial numbers and prices, and I can find which ones were outliers, buy the cheap ones, resell it, right? So I was able to do this for like a month, and it was pretty cool. But then they recently changed their website. So I was able just to use simple Arvest stuff to do this. But eventually they ended up changing their website. So let's go on to NBA Top Shot. Let's go to a player. So we talked about Julius Randle before. Here's one of his top shots. It's $3. There are 40,000 of them, right? But let's try to inspect. So if you wanted to buy these prices, clearly we have to click buttons, right? This is not just like a simple scrape thing. You have to click buttons. Once you do this, you automatically get some serial numbers and prices, right? So if I want to inspect this, and I want to like simulate how this data comes up, I'm going to open up network. I'm going to reload this. All right, so clearly no prices have come up yet. So what I can do is stop recording, restart recording. Now it's empty. Click this button. Prices pop up, stop recording. All right, so let's see what came up here. We have this fetch, which is a flags API. Not sure what any of this stuff means. There's this metrics ping. I'm not sure what that means. This is a Facebook thing. It's probably like an ad. API segments. This is an XHR file. This is the one I told you guys to look for. If we look at it though, it just says true. So clearly this is not the one that we're interested in. This is a Google Analytics thing. Here's a marketplace one, search minted moments. So search minted moments, we have, it went all the way to the end. We have data, oh geez. Sort by price, USD, ascending, filters, all sorts of stuff. But as we scroll, trying to see if there's prices here. So this one says owned by collector. Maybe there's information here. But anyway, there's these two fetch things. There's this one and there's get edition listing lowest price. So if we look at this one, here's a preview. You have data, get edition ID, data. Here's the play, here's the set, price range, minimum price, right? So this is the one, maybe we're interested in getting the minimum price of each NFT or something like this. So clearly we need to scrape this thing or crawl this thing to get the prices. So if we open this in a new tab, it says must provide query string data is null. So before we were able to open that XHR, that JSON file, and it just gave us the information we wanted. But this one is called a GraphQL, or it's a type of it's a new type of query language that like Facebook developed, I think, a few years ago. So it's like pretty cutting edge for a lot of websites to start using. So this might be something good that you want to start thinking about. But anyway, in order to scrape this, we have to load in this library GHQL. I'll put the link there and I'll start a connection. So I'm using this GraphQL client, URL equals link. So I'm starting a new connection. This one I think is a slightly different player. Oh, I just pulled this. Okay. Anyway, when you go to this thing here, you go to headers. If you scroll all the way down, you'll see this request payload. It's a little bit small, so I apologize. But effectively, there's a query right here. All I did was copy this string and I pasted it here. So this is the whole query. So I just copied and pasted the query and I saved it as query because this is the query that we're gonna submit to the GraphQL server for NBA Top Shot. So we're gonna start a new query and we're just gonna put all this stuff in here. And then what we gotta do is we have to tell what variables do we wanna query. So for example, you'll see here, we have input things here that we need to fill in using our variable data. Now, how do we get the variable data? If you go here, there's a variables tab down here. If you open this up, we see input, play ID, and set ID. So you can recreate this using an R list. So notice here, I have variable, the list, where input is equal to a list. So if I go back, variable input is a list of set ID and play ID. Set ID, play ID. I just filled in these two things. So then I'm going to execute my my query, and it's going to give me this whole big long thing. But effectively, if we look here, data get edition price range minimum $140 for this specific NFT that I picked earlier. So if you ever see GraphQL, you're going to want to go to this request payload. You have the query. You should recreate this variables object here in R, and then you just execute. There's a really good link here that taught me how to do it. So if you just kind of go through what this person is saying, you'll be able to follow along. So he makes a query. He does the same exact things, creates a variable list, and gets his results. So if you want to follow along with him, you can. Okay, so effectively, all we've done so far is just gone to the internet and found where data live. We've found data via HTML, via XHR, via JSON, whatever, and we've saved it, right? So each time you do this, you'd want to save this JSON object. You'd want to save your session. You'd want to save all of these things. So to start scraping stuff, let's kind of go back to this Nix data because it's pretty easy. Okay, so now we're going to read the HTML, but instead of reading the HTML from the internet like we did in the beginning, we're going to read it locally from our computer. So if I read this HTML, we're going to see this, but this is coming from my PC, and we're going to say this is my HTML. So it'll be helpful if we go back to the Nix file. All right, so we want this roster page here. So what I'm going to do is I'm going to right click on it, click inspect. And I clicked on right next to Kadeem Allen's name. So that's going to bring me right here. So you can see as I am looking at it, it'll highlight these things. So this TD is highlighting Kadeem Allen. If I just go up a little bit, I'll be able to see, okay, this is this one. If I go up again, this will pick the whole row. If I go up a little bit more, takes the whole table body, a little bit more, table head, column group, table. So you want to take the whole table. So if you go here, you can probably see ID equals roster. Not all things have IDs. Like for example, this one doesn't have an ID, this doesn't have an ID, this doesn't have an ID, this one does. So if you want to take this, you can right click on it, copy, copy selector. So if you copy the selector and you paste it in R, you'll just get hashtag roster. So you're going to want to put that in your node. So if I run this, I'm telling start with my HTML and find this roster node. So if I run this, you'll see I have a table, class, sortable, stats class, ID equals roster, right? This is the thing that we were looking for. Now, let's suppose I wanted instead, I only cared about this row, this first row or something. If I right click, copy selector for this, you'll notice now that it's going to say roster, T body, table row, and then the first element of this. So not everything has an ID, but everything can kind of be traced back to something that either has an ID or back even to the beginning of the HTML. So all you want to do is just copy that, put that into your node. On this, and then you'll have your table row. And then number is 0, that's Kadima Allen number. So instead, let's have roster here. And because I know it's an HTML table, I can just say it is an HTML table, and it'll give me the entire table, right, like that. So really, really simple. All you do is just get your HTML from your folder, read it, ask for what node you want. If it's a table, just tell it's a table, and then you can save it as roster. And then the problem with this is it still saves as a list for some reason. So it is a data frame. So I always just say as.data frame. I'm going to save over it as a roster. So now you should recognize this table because this is what we've been working with. I've added 2 columns to it in the folder. I've added player ID and I've added height in inches because you'd have to convert this, but pretty much this is exactly what I pulled from online. Any questions about that first one?
Alex, how did you add those 2 columns, the ID and the other one?
Manually, honestly. Yeah, I just manually did it. But if you wanted to do it, like for example, if you wanted to add height in inches,
Yes.
so let's talk about that. So let's look at roster height. You have 6-1. These are all in feet and inches, right? So the way I would do this is I would string split by the dash. So if you remember string split, I don't remember if it's first or second. Let's see. Okay, so now I have this, right? I've broken this apart. Now I'm going to unlist. Well, there's a few ways you can do this. You can unlist as that numeric. And I'll call this heights. Okay, so now heights, true, false. These are going to be all the every other one. So this is going to be their height in feet. So I'm going to multiply this by 12 to get inches, right? And then plus heights. And then the other ones. So this is going to be their height in inches. This would be roster height in inches. Now, it is a little bit more difficult to get the player ID. If we look at roster, there's no player ID to be had here, right? If we go back to here, though, the reason why there's a player ID is because they each have a hyperlink. So if I click on Kadeem Allen, he's got a player ID in his URL right here, right? So this is something that I'm really interested in because I want to be able to, maybe I want to visit his page specifically. So we'll talk about that in 1 second. But if you're crawling or if we're scraping one page, extracting multiple pages is also pretty easy. Let's talk about that first. So let's go to my folder. So the first thing I'm going to do is I'm going to list my files. So I have all these Txt files, right? All these HTML files. Say this is files. And now roster, I'm going to overwrite, pretend we didn't have it, but I'm going to save it as a list. So this is when I'm going to make a list of data frames. So this is when having lists is really, really helpful. So I'm going to make a list and I'm going to go for each file in files. Right, so files, looks like this. I'm going to say file, it's files 1, just so we can go through a singular time. So I'm going to take my file, I'm going to read it. I'm going to pull the roster ID tag. I'm going to convert it to a table. I'm going to ask it for it as a data frame, and I'm going to save that as temp. So now temp is going to look like this. This is the 2010 MBA roster for the Txt. Now I'm always going to save what file or what link I got this from. Every time you crawl or extract data, always say what thing it came from. This one in particular has no reference to the year. So if you're trying to make, the Txt roster over years, if you didn't put in this file vector, you have no idea what year this is from. All you have is their birthday and their experience. Maybe you could back out the year like that, but that sounds difficult. So make sure that every time you're doing this in a loop, you're always saving some sort of information on which iteration this observation came from. So if I run this, we look at temp again, it now has Txt 2010. So now I know what team they're on, and I know what year it is. Because remember, if this was the Memphis Grizzlies roster, I would have no idea it's the Grizzlies versus the Knicks. There's no indication here, so I have to include that. Okay, so then what I'm going to do is I'm going to save this into my roster list. So for each time through the loop, I'm going to append. So roster right now is length 0. So 0 plus 1. So the first element is going to be temp. The second time through the loop, temp will already be there in the list. So now I'll have the second observation will be the new temp, then 3 and then 4. So if I run this, it's done. Now roster. Now is this data frame as 10. This is the Kadeem Allen one. This is number 9. So these are the Txt rosters over from 2010 to 2019 or 2020. So in order to combine this, we're going to use rbind roster. So I've done this. I now have roster 1. It's got 190 observations and 10 variables. So we have number, player, position, height, weight, birthday, all this information. So 2011, 2012, 2013, 2014, so on. So this is when you have multiple URLs that you're scraping, multiple tables that you want on these links, and you can kind of smash them all together this way. Any questions? Okay. So let's extract non-tables or hyperlinks. So let's figure out how to make that column I made where I had Kadeem Allen's player ID, or the link to his page, really. That's what I care about more than his player ID. So let's go back to this example. We read this HTML, we have our roster, the data frame. Cool. Right. Now let's go back to this roster as an HTML. So instead, what I want to do is here's the table row that has Kadeem Allen. I open it up. Here's something that I'm interested in because I have class left data append CSV Allen KA01. This is his player ID and all this other information. If I keep opening this up, I have this A tag that has an href, which is the link to his page. So you can see if I hover over it, it has www.basketballreference.com/player/a/Kadeem Allen, right? So this is what I want to get. So when I go here, okay, I'm in my roster, but I want to keep going further. So HTML nodes, I'm going to ask for all the A nodes. If I ask for all the A nodes, I now have all these hrefs, or A with an href element. So the first one is players, Kadeem Allen. Here's his hyperlink. The next one is his college, so Arizona. But we don't care about colleges. We just care about his player ID. So let's save these as links. So the links I want to save a subset of them. Well, first I want to extract this part. So if I say this, say HTML attribute, href, it'll give me all those links. If I did this href before I got to the A tag, it's going to look for hrefs in roster, which there are none. You have to go deeper into it. You have to go deep into the A's. Okay, so now I have the hrefs. They look like this. See, this is links. And now we're dealing with text data, right? This is just strings. So we've just worked with these. We know exactly how these things work. We know how to copy paste them. We know how to gsub. We know how to substring, all that stuff. So what we want to do is we want to subset this where we're only keeping the ones that say players. So we can say, can we find players in links? Some of them we can, some of them we can't. These are the ones we want to keep. So now I have all the players URLs, and I have 23 of them in particular, and I have 23 observations for a roster, 23 observations. So now if I want to do roster player ID, I can save this as this. Now roster looks like this. If I want to get rid of all this stuff, right? We know how to gsub. We can do gsub something roster player ID. All right, so we want to get rid of /players/alpha, right? Because we just want whatever it says / we want to replace that with nothing. But we also want to get rid of HTML at the end of the string, right? So there's still this little period at the end, so we have to get rid of the period.html. That's how you get the player ID. So this will be helpful for scraping their pages, right? Because you don't just want the roster, you want like information about Kadeem Allen. You want his Twitter, you want his height, you want his weight, you want, well, I guess height and weight exist there already, but if you go to Kadeem Allen's page, here's his Twitter account. Here's his Big Bruiser nickname. Here's his when he was born, where he was born, his high school, his draft, all this other information that now you might want. So if you have these links, you can use this and you can traverse, and then you can take these and you can start to scrape their stuff. So if we wanted to do this, links looks like this. We want just these ones. Roster, player link. Like this, you have to include the basketball reference beginning. Let me just go here. So roster, player link. So if I paste this to it, it's going to look like an actual URL. There's actually 2 slashes here, so I need to get rid of this guy. Now you can write a for loop and you can access each one of these things, saving it and then scraping it. So I just preached the whole thing about wanting to crawl it first and save it and then scrape it afterwards, but I'll just do the basic. I'll just scrape it without saving it. So for link in roster player links, you can do link HTML. So let's just set roster player link. Let's just see if we can scrape some of Kadeem Allen stuff, and then we can just generalize it into this loop. All right, so now link is equal to Kadeem Allen's thing. Okay, so let's say we want to grab his Twitter. We want this thing right here. So what we're going to do is we're going to inspect. Go to this. You kind of, wherever you are, you kind of go up until you see it highlight kind of the entire thing. Here's one that says has an ID, so we can just use hashtag meta. So we're going to use this HTML nodes hashtag meta. Now we're in this div ID meta. All right. So if we want his Twitter, we have to ask for all the A nodes, right? If we ask for the A nodes, we get a bunch. So there's this Twitter, but it's just the link to Twitter itself. And here's his Twitter name. So his link to his actual Twitter. So if we want this one, again, we have to take the attribute. And we're working with strings again, right? We just want to subset and pull this one. So maybe we want to say this is going to be links where we can find twitter.com. So then we have his thing. And then we can assign this to his entry in the data frame, and we could just kind of keep going through this over and over and over again. So if you wanted to print everyone's Twitter link because you want to follow them or see what they have to say. Kadeem Allen, Ron Baker, Trey Burke, all these guys' Twitter accounts. Any questions about that? Hopefully you should recognize like it's a combination of strings, loops, and lists, all things that we've covered already, just in a more comprehensive way.
Okay, Alex, if I want to add this as a column to my list, how do I do this after extracting it?
Okay, that's a good question. So I just said that, but I didn't actually do it. So let's do it. Okay, so you know that you have this link, right? So I want to say roster tweeter, and I'm going to set this as NA, right? Maybe I want to set this as NA beforehand. So now everyone's got a blank tweeter, right? So now we want to set this as roster tweeter. However, if I do this, right, if I run this loop, okay, so it gave me an error. But also notice how everybody's got the same Twitter because I haven't set it to one specific person. So what I need to do is I need to specify which one it is. Now, I don't have I in this for loop. Like if it was I in 1 to n row, I could easily just put an I here. But I don't actually have that. So this is another function that's really helpful. It's called the which function. And it'll tell you the index of the true and false of the trues in a vector. So if I say roster player link, right, here are all the player links, equals link, only one of these is going to be true because I'm going through them, right? So only the last one will be true. So this will give me the location of where I need to put this Twitter link. So now if I run this again, oh, I think I just added basketball reference to it like a million times. Yeah. Okay. Roster links. All right, so it keeps giving me this error. This is because the last guy doesn't have a Twitter account. So we'll just pretend like he does and I'm not getting the error. But if we go back to roster, we'll see a different Twitter account for each person. So you can go to other websites, pull this stuff, information, but for example, you're going to want to not scrape right away. You're going to want to crawl it and save it somewhere. So you can always go back to it if you need to. Any other questions about that? Again, it's really heterogeneous, so it's really hard to kind of come up with a specific example right off the bat. So here's some Twitter account stuff. Okay, one more thing. Websites break all the time. So links are dead. You're looping through something, and maybe for some reason the Knicks didn't play in 2019 or something like that, or something happens, but you can kind of anticipate it. Like, for example, if you're scraping and you get a 404 error because the website took too long to respond, or there's a server down or something like this, and you can anticipate it, you can use this thing called try catch. So for example, if I try to scrape or crawl the Knicks 3019 roster, obviously this is not going to work. There is no year 3019 yet. So if we go here, it'll yell at me 404 error. So when I try to crawl it, the result will be an error, 404. So it says, hey man, not working. Your R script will break and then you will be sad. So in order to avoid being sad, you can use this try catch. So what you do is you put the potentially problematic code in the first try catch thing. And then you can specify, hey, what happens if there's an error? If there's an error, just print 404 error, try again, and then you can keep moving and your code will keep looping. So you don't have to actually stop your loop and start all over again and stuff like this. There's other ways to kind of build in not having to double crawl or double scrape or something like this, but this is a pretty good handy way to do it. So for example, this one will just print 404 error, try again instead of this much scarier version. And then if you do something that will work, the 2019 one, you'll just get the normal output. So it'll just work as expected. So this is a really helpful thing if you're kind of getting stuck on certain things, or maybe you're getting blocked occasionally or whatever, right? You can program some stuff like this. I want to talk a little bit about our Selenium. So sometimes if JavaScript is the thing that's pulling the data, it's still difficult. So even though there's GraphQL, even though there's these JSON backends, even still, sometimes it just won't work. There's a tool called our Selenium, which is terrible because it's always being, the maintainer is always being passed around and stuff like this. It's not good. But in Python, it's really easy to set up. And if you ever come across a situation where you need to use this, you can always email me and I can send you some pointers or some code. But effectively what Selenium does is it simulates a user experience. So literally on your screen, a browser will pop up, and it's like kind of freaky because if you program scrolls or if you program typing or mouse movements, it'll do all of that stuff. So you're really simulating a browser experience, and it'll load all the JSON because you're completely faking out the website and the server. So it's really cool to do it in Python. I would suggest not doing it in R, it's just too hard. But again, what you can do is you can open up the website, click on the things you need to click on, load what you need to load, save the HTML, and then you can read it in R and do all your scraping in R. Another thing I always get asked about is scraping PDFs. Don't do it. It's miserable experience. It's a ton of string work. Even if you can scrape it, like this is even if you can get the text data into R, it's just really hard to do, just because not everything's always lined up, stuff like this. Like here's an example of PDFs I did end up scraping for some stuff where everything's pretty formatted, but even still I had to figure out like how many spaces were between this versus this, players' names and all this stuff is really difficult. So I would just say stay away from it as much as you possibly can. There are some notes that I've seen on Twitter using some like optical recognition software to get stuff that's not necessarily like programmed like that. And you can like kind of have the computer read it for you. I think the woman's at Harvard or something who built it. That's pretty cool, but I have no experience with it, so I'm not going to talk about it. Are there any questions about web scraping? Does anyone have an immediate need that maybe we can kind of like look at right now?
Yeah, this kind of back to the very beginning. I could not get the write HTML function to work.
Right,
It kept
HTML.
giving me some Julia error. And I tried looking up, it said I needed some package IAI, and then even then it couldn't work. So I didn't know what was going on with that.
What operating system do you have? Windows?
Yeah, Windows.
I had the same error, but I got a different message. I had to install XML2.
Same here. Yeah, XML2.
So once I did that, it worked. So maybe try that.
Okay, let me try that.
Maybe try loading in XML2. I know RVest has that. Like whenever you load in RVest, it pops up. I don't know if I can go back far enough, but yeah. So maybe try doing that. But yeah, I'm not sure. I've never heard of that IAI package. If it's still giving you problems after you load in XML2, just send me an email and we'll talk about it after.
Okay, thank you, Alex.
Did anybody have a website that they wanted to try scraping now? Well, let me stop the record.